Hello student, welcome you all in the third video related to the Bohr's atomic model. We are discussing about the applications of the Bohr's atomic model. Why I choose this topic? Because I found so many questions they are asking to calculate the radius, energy, velocity or radius ratio, energy ratio, velocity ratio. Although this concept is rejected but numerical oriented for the NEET, JEE and other competitive examination if you are preparing for any examination after 12th. So these videos are very important for you. Energy of electron in an orbit, all formula I am going to discuss. Oh sir, see here my dear student, you are saying every video is going to start with a complex formula. But my dear student, I am here to make it simplified. Just some of the student have a curiosity. Why these formula are coming? From where you got this formula? They are asking so many questions. For the satisfaction of this kind of a student, I have this formula. I think they over satisfied by seeing this formula. Okay, energy of an earth orbit is given by 2 pi square m, where m is the mass of the electron, k proportionality constant, z atomic number is square, electron the charge of electron, n is the nth orbit and h is the Planck's constant. Try to find out and tell me which one of the following variables are not constant. Among these you will observe that only n square and z square is not constant. These highlighted variables. So you can say, sir, energy is directly proportional to the atomic number square while energy is inversely proportional to n square. Okay, although it is directly proportional, I will explain what the consequence of having negative sign in all these formulas. Okay, now let's start. Here very important thing that I want to tell you, all the students, some of the students last year they remember the formula and attempt the question in a wrong way because they are confused with the units. If they are asking to calculate the energy of an earth orbit in electron volt, then you have to use this formula, that is energy of an earth orbit is equal to minus 13.6 into z square upon n square. This formula is valid for hydrogen and hydrogen like species. If you are using only hydrogen atom, you have to put here 1 because atomic number of hydrogen is 1. Electron volt per atom. Energy of electron in nth orbit. If they are asking to calculate the energy of electron in an earth orbit in kilocalories per mole, if the question is indicating calculate the energy of electron in an earth orbit in kilocalorie per mole, then you have to use this formula minus 13.3, okay, 313.6 z square upon n square. Take the screenshot of all these important formula. And if you have to calculate the energy of electron in an orbit in joule per atom, then you have to use minus 2.18 into 10 to the power minus 18 z square upon n square. You can replace z by 1 if you are using hydrogen atom, and if you are using hydrogen like species, then you have to put the atomic number of that species. Okay, and if you are using the question asks to calculate the energy of an earth orbit in kilojoule per atom, then you have to use this formula minus 1312, okay, into z square upon n square, 1312 into z square upon n square, and the unit is kilojoule per atom. More than remembering the formula, the knowledge of units are important. Without unit, you can do some big blunder mistake. So remember all the units and their constant values. Now, my dear student, there is little confusion when I was discussing the Bohr's atomic model. I was saying that energy of the first orbit is minimum. As we move up, energy increases. That is, the energy of the orbit that is far away from the nucleus will be high. So energy should be directly proportional to the orbit number. But here in all the relation, my dear students, see here, energy seems to be inversely proportional to the orbit number, because I am using negative symbol here. So listen carefully. This, as energy is equal directly proportional to minus 1 upon n square, so energy of electron increases as we move away from the nucleus. Minus a negative number, if it is in negative decreasing, it will obviously increasing. Okay, so as n increases, you can say n increases, energy, negative value of energy will decrease, but my dear student, the positive value will increase. I think you have integral knowledge and knowledge of integral line, 0, minus 1, minus 2, 0, 1, 2, 3. Okay, and one thing that I want to discuss is not important for the school examination. This is very important, the total energy of electron. Sometimes they are not asking to calculate the exact value. They want to ask the relation between the total energy and kinetic energy and the potential energy. Then my dear student, you can use this formula that the total energy, TE means total energy, is equal to potential energy by 2. It means you can say the total energy is half of the potential energy. Okay, and total energy is a negative of the kinetic energy. So many questions, my dear student, you will not trust me. They are giving the value of total energy of the electron revolving in an orbit is this, find out the value of the kinetic energy. Some of the students are thinking, what is the formula? No formula, just put change the sign. If they are giving the value positive value, put the negative value, negative of the same magnitude, only sign change. So this formula will be going to be very important if you have some target in your mind for the NEET and JEE examination. Okay, now moving to the other concepts that are very important for you. See here, this is just like the solar system. You are thinking the Bohr's atomic model is now connected with the solar system in the classes, and you can see my other videos where I discussed that the Bohr's atomic model could also be related to the planetary model of an atom. Okay, so it is the nucleus, the first orbit, second orbit, third orbit, fourth orbit, and so on. You have to remember to calculate the energy of that orbit. But I think if you want to save the time, then at least up to orbit number 4 or 5 you have to remember the values. The electron present in the first orbit is said to be in the ground state, or the most stable electron. Okay, because of the least energy. While when the electron jump from n is equal to 1 to any of the higher energy level, it is said to be the excited state. If electron is present in the second orbit, it will be called the first excited state. If electron is present in the third orbit, it will be called as the second excited state, and so on. If I said one electron is present in the third excited state, the orbit number will be 4, one higher than the number of excited state. Okay, I request you all to write all these values. When electron is present in the first orbit, the energy of that electron will be minus 13.6 electron volt. The unit is electron volt, remember. N is equal to 2 minus 3.4 electron volt. N is equal to 3 minus 1.51 electron volt. N is equal to 4 minus 0.84 electron volt, and so on, remember. Up to 4, my dear. I request you to remember the values up to 4 only. Total energy of free electron at rest is 0. Total energy of free electron at rest is 0. This question can be asked, although electron will never be at rest. These are assumption of the Bohr's. But you have to remember, Bohr's created some problem for us, but you have to pass the exam. So you have to remember. Okay. Energy of electron inside the atom is negative. Then after, my dear student, they may ask you to calculate the energy ratio, just like radius ratio, and you also calculated the velocity ratio, and then finally they can ask to calculate the energy ratio. Energy ratio of different orbit of the same atom. They are asking the different orbit. For example, they are asking the radius ratio of the lithium atom or hydrogen atom, the same atom but two different orbit. First orbit of the lithium and the fourth orbit of the lithium. Atom is same but the orbit is different. Then you can use this formula, energy of the first orbit or that orbit, maybe second or third, whatever it be. Okay, n2 upon n1 square, n2 upon n1 square. So E1 upon E2 is equal to n2 upon n1 whole square will help you to calculate the energy ratio of different orbit of the same atom. Remember, same atom, but energy ratio of different orbit of different atom. If it is they are different atom, you have to put the value of the atomic number of that atom. E1 upon E2 is equal to Z1 upon Z2 N2 upon N1 whole square. Whole square. This formula is also very important. If you remember the formula about the energy, radius and the velocity, then I'm giving you the guarantee that you can solve all the questions that can come in your JEE or NEET or any school examination. Live, I am saying, you can solve all the questions. I collected all the formula based on the previous year question papers and the trends they are asking the question. Remember this formula and then see the change in yourself. Thank you so much for watching this video, and we'll meet you in the next video with another topic. You can comment which topic you want to listen with me. Thank you so much.